Welcome back, everyone. I'm Alejandro, owner of Tutoring by Alejandro, and one of the topics that almost every chemistry student struggles with is stoichiometry. So, at first glance, the word looks intimidating, stoichiometry, but in the end, it really just means using balanced chemical equations to calculate the amount of reactants and products in a reaction. So, this video, I'll explain what stoichiometry is in simple terms, and then we'll work through 5 practice problems step by step, so you'll see exactly how to solve them. Okay, so what is stoichiometry? So whenever we write a chemical equation, like for example, 2H2 plus oxygen produces 2H2O, right? The numbers in front of each compound, so this 2, you have a 1 here, right? And this 2 here, okay? Those are called coefficients. So these are coefficients. And these tell us the ratio of molecules that react and are produced, okay? So stoichiometry is simply using those ratios to answer questions like, if I start with, this many grams of oxygen, how much water will I get? If I only have a limited amount of hydrogen, which reactant runs out first? How efficient was my reaction compared to what I should have gotten in theory? So in the end, stoichiometry problems, they boil down to the same 4-step process, okay? So the first one is you have to balance the equation, okay, if it's not already balanced, okay? Then you're going to convert the given amount to moles, okay? So when you're comparing ratios, you always want to compare them in terms of moles. And you're going to use the mole ratio from the equation. You're going to build your mole ratio from the equation. Okay, and then in the end, you're going to convert into the unit you want. Okay, great. So that's basically the gist of it. We're going to put this into practice with 5 examples. So as I'm erasing this, I'll read you the first problem. So we have, given the reaction, nitrogen plus 3 hydrogens, right, produces 2 ammonias, right, NH3. If you start with 4 moles of H2, how many moles of NH3 are produced? Okay, so let's put into practice what I was talking about. Okay, we are going to see if the equation is balanced, right? So we have N2, 3H2 produces 2NH3. Okay, so on the left, there are 2 nitrogens, right? And right here. And on the right, you have, again, 2 nitrogens, right? Because this 2 basically is multiplying, right? Each of these terms, right? Okay, so that checks out. What about the hydrogens? So we have 3 times 2. That means I have 6 hydrogens here. And then I have 2 times 3, which also gives me 6 hydrogens. Okay, so the chemical equation is balanced, so we can move on to the next step, right? Which is converting the given amount into moles. Thankfully, for this exercise, we've already been given moles, so no issue there. So now we're gonna construct mole ratios from the equation in order to convert into the unit we want. Okay, so we are starting out with 4 moles of hydrogen, right? How many moles of NH3 are produced? Okay, so we want to build a ratio of hydrogen to NH3, okay? And a mole ratio is kind of like building a unit factor, right? You may have watched my video of unit factors. So based on the equation, the balanced chemical equation, for every 3 moles, okay, of hydrogen, we'll get 2 moles of NH3, okay? All right? Or we can write it the other way, right? For every 2 moles of NH3, we'll get 3 moles of H2, right? Okay. Well, now we're going to decide which of those mole ratios, or you can call them unit factors, to use. So we have to make sure we end up with moles of NH3 in the end. So let's write out the full units. So we have 4 moles of H2 multiplied times. Now, since we want to cancel out moles of hydrogen, we want the mole ratio with moles of hydrogen in the denominator, so they'll cancel out. So we'll use this one here, right? Okay, great. So it's going to be 2 moles of NH3 divided by 3 moles of hydrogen. Okay, so since we have moles of H2 here, up here, and moles of H2 down there, they can cancel out. And you will see that the unit I'm left with is moles of NH3. So now you can just use your calculator and calculate 4 times 2 is 8 divided by 3. That gives you 2.67 moles of NH3. Okay, so if you start with 4 moles of hydrogen, you will produce 2.67 moles of NH3. Okay, let's move on to the next exercise. Okay, so now we have the reaction 2H2 plus O2 produces 2H2O. And they're asking how many grams of H2O are produced from 16 grams of O2. So let's write down the equation. 2H2 plus O2 produces 2H2O. Okay, we'll have to see if the equation is balanced. So here on the left, we have 2 times 2, that gives me 4 hydrogens. And then 1 times 2 gives me 2 oxygens on the left side, right? Okay, great. And on the right side, we have 2 times 2 is equal to 4 hydrogens, right? And then this 2 also multiplies the O, right? So that means I have 2 oxygens on the right. Okay, so that means we do have a balanced equation. So that's good. Okay, we can keep going. So the next step I mentioned is we have to convert everything into moles, right? We cannot compare 2 different substances in terms of grams. We have to use moles. Okay, so they're saying we have 16 grams of O2. Okay, we have to convert that into moles. So we have to construct a unit factor, okay? A gram to mole unit factor. So we can build this in 2 ways, right? Okay, so O2, each oxygen has a mass of 16, right? So O2 is going to have 32 grams, okay, of O2 per 1 mole of O2, right? Okay, or we can build this the other way. We have 1 mole of O2 has 32 grams of O2, okay? And again, which unit factor we use depends on what units we need in the end, okay? Since we're starting out with grams and we want moles, we need to cancel out the grams. So we want the unit factor that has grams in the denominator, so they'll cancel out. So that means we want this guy right here. Okay, so that means I'm going to multiply 16 grams of oxygen by 1 mole of O2 divided by 32 grams of O2. Okay, so that means I can cancel out my grams with grams, right? These two cancel out, and that means my units will be in moles. And I have 16 divided by 32 moles of O2, right? That gives me 0.50, right? Or 1/2, half a mole of O2. Okay, great. Now we have to obtain the mole ratios. Okay, so we are comparing, based on what the problem is asking, H2O to O2, right? Okay, so again, this is very similar to constructing unit factors. So we're saying, based on the equation, that 1 mole of O2, right, generates 2 moles of H2O, okay? Or we can write it the other way, right? 2 moles of H2O are produced from 1 mole of O2, okay? So I can use either of those, depends on the situation. Okay, so let's begin. So at this point, we know the quantity of O2 in moles, so let's start with that. So we have 0.50 moles of O2, right? Now we're going to convert that into moles of H2O, right? So since I want to cancel out moles of oxygen, I am going to use the second, mole ratio that I found, right? So that is 2 moles of H2O over 1 mole of O2, okay? These cancel out, right? And that gives me 0.50 times 2, right? That's just 1 mole of H2O, okay? But I'm not done yet. They're asking for grams, so I need to create another unit factor, right? In order to convert that into grams. So we know that 1 mole of H2O has 18 grams of H2O, right? Why? Because the oxygen is 16, right? And each hydrogen, each H, is 1. So 16 plus 2 gives me 18. Okay, so the moles of H2O cancel out, and I'm left with units of grams. And then the math is easy. It's just 1 times 18. So my result is 18 grams of H2O. That is our result. That is how many grams of H2O are produced from 16 grams of oxygen. Okay, let's move on to the next exercise. Okay, now we have the reaction CH4, methane, plus 2O2 produces CO2, carbon dioxide, plus 2H2O. Okay, and they're asking how many liters of CO2 at standard temperature and pressure, STP, are produced from 10 grams of CH4. They're giving a hint. It's saying at STP, 1 mole of gas is equal to 22.4 liters. Okay, so quickly, let's see if the equation is balanced. So we have CH4 plus 2O2 produces CO2 plus 2H2O. So on the left side, we have 1 carbon, right? On the right side, we have 1 carbon. left side we have 4 H's, right? And on the right side we have 2 times 2 gives me 4H, right? On the left side we have 2 times 2 gives me 4O. And on the other side I have 2 here, right? And then I have 2 more here from the H2O. So that's 2 plus 2 gives me 4O. Okay, great. So the chemical equation is balanced, right? That's good. Next, we have to basically convert whatever we need to into moles, right? Again, we have to compare it in terms of moles. So we have 10 grams of CH4. 10 grams of CH4. So, like we did earlier, we're going to have to construct some, let's call them unit factors, right? In order to cancel the grams of CH4 and obtain moles of CH4. So we're going to multiply by, we want grams of CH4 in the denominator and moles in the numerator. So 1 mole of CH4 has how many grams? So carbon is 12, right? And each hydrogen is 1, so that's 12 plus 4 gives me 16 grams of CH4, right? So those cancel out. Okay, that cancels out. And I'm left with 10 over 16 moles of CH4. Okay, if we calculate that, we get approximately 0.623 moles of CH4. Okay, so we have the moles of methane, okay, and we need a comparison with CO2. So based on the chemical equation, we know that 1 mole of CH4 produces 1 mole of carbon dioxide. It's a 1-to-1 mole ratio. Okay, so that means if we had 0.623 moles of methane, we're going to produce 0.623 moles of carbon dioxide. Okay, great. But again, they're asking for liters. So how do we get liters? Well, thankfully they gave us the hint. They're saying 1 mole of gas is equal to 22.4 liters. So we'll create, we'll create a unit factor based on that. So we're saying that 1 mole of CO2, it has 22.4 liters of CO2, right? Okay, now we can cancel out the moles, right? And that leaves me with units of liters. So 0.623 times 22.4, that gives me 13.9 liters of CO2. So about 14 liters of CO2 are produced from 10 grams of methane. Okay, let's move on to the next one. Okay, so now we have the reaction 2 aluminum, 2Al plus 3 chloride, Cl2, produces 2 aluminum chloride, 2AlCl3. All right. If 5 grams of Al react with 10 grams of Cl2, which reactant is limiting, and how many grams of AlCl3 are formed? So this question is a little bit different than the previous ones, because now there is a limiting reactant. And the way this works is, in order to find out how many grams of AlCl3 are formed, the comparison that we need to make, the mole ratio, has to be in terms of whichever reactant is limiting. So we have to find that out first. But before that, let's just do a quick check, make sure the reaction, the chemical equation is balanced. Okay. Okay, so we have 2Al on the left, and we have 2Al on the right. And then we have 3 times 2 gives me 6Cl on the left. And then 2 times 3 gives me 6Cl. Okay, so everything checks out. That's good. By the way, let me know if you want me to make a video on balancing chemical equations in the future. Just a thought. Okay. So, let's find out what's the limiting reactant. Let's calculate the moles of Al and the moles of Cl2 based on the gram quantities. Okay, so moles of Al. So we have 5 grams of Al multiplied, right? We need to cancel out the grams. So each Al, each aluminum, is 26.98 grams per mole. Okay, per mole of Al. Okay, all right, those grams will cancel out, and we will be left with 5 divided by 26.98 gives me 0.185 moles of aluminum. Okay. Similarly, with the chloride, we have, they're saying we have 10 grams of Cl2, okay, multiplied by, so we have 2 Cls, each of them are about 35 or so. Let me see the exact quantity. Okay, so I have that 1 mole of Cl2 has 70.90 grams of Cl2. Okay, and like we did with the aluminum, the grams cancel out. We divide 10 by 70.90, and that gives us 0.141 moles of Cl2. Okay. So, what we need to do is we need to find out. So, right, which reactant is limiting. So, if based on the chemical equation, for every 2 moles of Al react with 3 moles of Cl2. Okay, so it's a 2 to 3 relationship. Okay, 2 to 3. So if we have, let's see, we have 0.185 moles of Al. Okay, what does that give us? Based on the mole ratio, we should use 2 moles of Al, 3 moles of Cl2, okay? And canceling out moles and moles, okay? That gives me 0.278 moles of chloride, okay? So that's what I would need. So 0.278 moles of chloride is what I would need to react with 0.185 moles of aluminum. But we have 0.141, which means it's not enough, right? It's not enough to react with the 0.185 moles of aluminum. So that means that this guy here, the Cl2, is the limiting reactant. And since it's the limiting reactant, we're going to base our future calculations on Cl2, okay? Right, so in order to find out how many grams of AlCl3 are formed, we have to use the information for the Cl2. Okay, so from here on, it's very similar to the other exercises. So we have 0.141 moles of Cl2, right? We create our unit factor here. So based on the chemical equation, we have 3 moles of Cl2, right? And produce 2 moles of AlCl3, okay? And then we have, let's see, 0.141 times 2/3, right? These cancel out. That gives me 0.094 moles of AlCl3, okay? All right, and then the final step, let's just convert that to grams. So this gets multiplied by, we have 1 mole in the denominator because that's what we're trying to get rid of, right? Okay, and 1 mole of that has, according to the periodic table, 133.34 grams of AlCl3. Okay, so again, moles cancel out. I'm left with grams, and my answer is approximately 12.5 grams of AlCl3. Okay, and that is my answer for this exercise. Okay, moving on. Okay, this is our final exercise for the day. So we have the reaction calcium carbonate produces calcium oxide plus carbon dioxide. So let's write that down. Okay, great. If 50 grams of CaCO3 are decomposed and 20 grams of CaO are obtained, what is the percent yield? So the percent yield comes into play when we're expecting, based on the calculations, a certain amount of CaO, based on the mole ratios, that we obtain from the balanced chemical equation. But in real life, we suffer some losses, right? So we're pretty much never going to obtain what we think we will. So what we're calculating in these exercises is a theoretical amount, okay? So when we compare the actual amount versus the theoretical amount, that's what gives us our percent yield, okay? But for now, let's solve this exercise just like we would a normal one, okay? Check if the equation is balanced. Yes, it is, right? We have 1 calcium on the left, 1 on the right, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, 3 oxygens on the right. And we have 50 grams of calcium carbonate, right? 50 grams of calcium carbonate, which we have to convert into moles, right? We always deal with moles. So we want the grams in the bottom and the moles in the numerator. So that 1 mole of CaCO3 has, so according to this, it is 100.1 grams of calcium carbonate per mole. Okay. Cancel out the grams. Okay. Divide 50 by 100.1. That gives us approximately 0.5 moles. 0.5 moles of CaCO3. Okay. So now with this, 0.5 moles of CaCO3, we're going to calculate what amount of CaO, calcium oxide, we should obtain, right? Basically what we've been doing in these past exercises. That's the theoretical amount. So we're going to use the mole ratio from the balanced chemical equation, which tells me that 1 mole of CaCO3 produces 1 mole of CaO, right? 1 mole of CaO, and which basically also gives me 0.5 moles of CaO, right? Okay, 0.5 moles of CaO. We'll convert that into grams, our theoretical grams. So 1 mole of CaO has, so let's see, that is 56.1 grams of CaO. Okay. Multiplying them, canceling out the units, right? Canceling the moles out. 0.5 times 56.1 gives me about 28 grams of CaO. So this is our theoretical quantity, right? This guy here, the 20, is the actual. Okay, so the percent yield is going to be equal to 20, which is our actual, divided by our theoretical, which is 28, right? And then multiplied by 100. And this gives me 71.4%. That is our percent yield, okay? So there you have it, 5 types of stoichiometry problems. We did mole to mole, grams to grams, grams to liters, limiting reactant, and a percent yield. So, but the key is use the same 4-step process. Balance the equation, or at least check that it's balanced. Convert to moles, right? We want to do our comparisons in terms of moles. Build your mole ratios or, unit factors. And then convert back into the unit you need, okay? So I hope you found this walkthrough helpful. Make sure to like and subscribe for more tutorials. And, I'm doing chemistry, math, physics. I'm going to throw in some engineering in there. If you want one-on-one help, I'd be very glad to work with you. Thanks for watching, and I'll see you in the next video. Bye-bye.